So in the previous video, we've seen how Now Based Xss can be exploited. So we've seen attacks, Now Based Xss attacks, and in this video, we're actually going to look into protecting your users or yourself against maybe your users, because I'm assuming that you're an application security professional, protecting your users or a wannabe one against Now Based Xss attacks. So what I want to say is that I'm not going to give a deep dive into this because we've covered in the lessons, we've covered a lot of XSS over here in a previous video. I believe it was video number 2 or 3. So cross-site scripting attacks, cross-site scripting defenses. This is a lengthier video in which I cover general defenses against cross-site scripting attacks. Now, in this video, we're actually going to look into the specifics of protecting your users against Now Based Xss. So cross-site scripting, as we've seen, is one of the most common ways hackers attack websites. Now, the prevalence of Now Based is relatively rare, exploitability is quite easy, and impact is quite harmful. That being said, I don't actually intentionally look for this in my application security assessments outside of the very basic or generic stuff. So, Now Based Xss attacks have all the risk associated with the other types of XSS, with the added bonus that they are impossible to detect from the server side, because you do not know actually, because the logic is actually on the client side. Any page that uses URI fragments is potentially at risk from XSS attacks. So as an application security professional, whenever you see URI fragments, and we've seen that in the previous video, in the attacks video, you know that you might be dealing with, in theory, with a Now Based Xss. So you should be testing for that. Want to see this vulnerability in action? We've seen it in the previous video. Now, how do you protect against this? Protecting against Now Based Xss is a matter of checking that your JavaScript does not interpret URI fragments in an unsafe manner, and we've seen what unsafe manner is in the previous video. So, frameworks like Angular and React use templates that make construction of an ad hoc HTML an explicit and rare action. This will push your development team towards best practices and make unsafe operations easier to detect. So, you're quite covered if you're using Angular and React, which is what I said in the previous video about modern frameworks. In Angular, and why I don't look for XSS in general. In Angular and dynamic content written out in curly brackets, this will automatically be escaped. So the following is actually safe. So anything that's written in curly brackets in Angular is actually escaped. This is actually safe. But in this situation, be wary of any code that bins dynamic content to the inner HTML attributes, since this is not escaped automatically in Angular. So this situation in which you bin dynamic content to inner HTML, this is actually not escaped automatically. So you have to make sure that you're actually escaping that parameter. Now in React, similar to Angular, any dynamic content written out in curly brackets will automatically be escaped, such as in single curly brackets. In Angular, we've seen that it's in double curly brackets. Now, React allows you to use dangerously set inner HTML, which is actually named to remind you that it's quite dangerous. So you can actually spot a potential Now Based Xss when you see a situation like this. Dangerously set inner HTML, and in this situation you have the single curly brackets with the dynamic content that you want to render. So sometimes a full JavaScript framework is too heavy weight for your site. That's why, and that's actually the situation when these types of attacks occur, because you're not using a full JavaScript framework, you're actually using something custom. In that case, you will need to regularly conduct reviews to spot locations that reference window.location.hash or window.location, or there are a few others. So it's also, you should also look for document.write, outer HTML, inner HTML, and to actually those actually signal the possible existence of a DOM-based XSS. Consider coming up with an agreed coding standard on your URI fragments, on how your URI fragments are to be written and interpreted, and centralize this logic in a core library. So if you use jQuery, carefully check any code that uses the HTML function. So this is highlighted in red. If you are constructing raw HTML on the client side on the back of untrusted input, you may have a problem whether the input comes from a URI fragment or not. Use the text function whenever possible. So as I said, if you're using direct the native DOM APIs, you should avoid using properties such as inner, outer, HTML, document.write, window.location.hash. Instead, set the context within tags, whatever possible, such as text content. You should also parse JSON carefully and do not evaluate JSON to convert it to native JavaScript objects. For example, by using the eval function, eval, instead use json.parse. You can also protect against DOM-based XSS by detecting unsafe code using development tools such as Burp Suite, which is actually the work of cybersecurity or application security professionals. Again, do not use URI fragments at all. The most secure code is the code that isn't there. If you don't need to use URI fragments, then don't. So you can write a unit test to scan your JavaScript for mentions of window.location.hash and have it fail if the pattern is found. When there is a need to use URI fragments, then you can discuss how to ensure their safe use and their escape properly. Sort of like. Implement a content security policy. Now this is actually the general rule when it comes to, or user types more recently, when it comes to actually preventing a lot of hurdle with XSS. Modern browsers support CSPs that allow the author of a web page to control where JavaScript and other resources can be loaded and executed from. XSS relies on the hacker being able to run malicious scripts on a user web page, either by injecting directly somewhere within the HTML or tricking the browser into loading the JavaScript from a malicious third-party domain. And this is where content security policy actually does its job. It actually controls where you are able to load script from. By sending a CSP in the response header, you can tell the browser to never execute inline JavaScript with this one, and to lock down which domains can host JS for a page. So in this situation, you have a content script policy, script source self, and also apis.google.com. So in this case, you're actually whitelisting apis.google.com, and you're implicitly stating that inline JavaScript is not allowed. So this is implicit and not explicit. By actually specifying the domain that you allow, you're implicitly denying everything else. The content security policy can also be set in a meta tag or in the head tag in the browser with meta HTTP equivalent. Now this approach will protect quite effectively. However, it may take a considerable amount of discipline to make your site ready for such a header. Inline script tags are considered bad practices, like this one, as well as mixing content and code. This actually makes web applications difficult to maintain, but are common in older legacy websites. And from my experience, I could actually tell you that there is still a lot of that practice. So even though we want to actually build modern applications, sometimes, many times, most times, there is a burden of actually not building. There have been applications that are around for like 7, 8, or 9 years, and they carry a lot of old code in them, which is why it's actually very hard, developmentally speaking, to write everything from scratch, which is why developers often have to resort to situations like this one where they're actually mixing HTML with CSS and with JavaScript all in the same, all under the same roof, so to speak, and that actually opens the room for a lot of issues. Now, to migrate away from inline scripts incrementally, consider using violation reports by adding a report URI. We've talked about report URI in a previous video, such as whenever your content security policy is violated, this will actually send this will automatically send a post request to the report URI that has been specified, and in turn this will actually give you a reassurance that there are no lingering inline scripts before you ban them outright. So there are a few further readings for this one. How XSS is working on content security policy from a weblog from Mozilla, Now Based Xss scripting vulnerability from NetSparker, and CSP explained also by NetSparker. Now let's test ourselves. Let me see, we're 11 minutes in, we're quite okay. Which of the following statements are true regarding URI fragments? Changing the fragment in JavaScript will not cause the browser to refresh the page. I would say this is true. URI fragments are not sent to the server. This is also true. What is a URI fragment? The part of the URL after the first / character, the part of the URL after a hash character, the part of the URL after a question mark character. If you use HTML function in jQuery, what should you be wary of? The user's password may be HTML. Untrusted input passed directly to HTML, which may allow an attacker to inject malicious JavaScript. There is no HTML function in jQuery. Alright, now in the next video we are actually going to start looking at file upload vulnerabilities.